Alright, so I'm going to be explaining question 13 through 16. For question 13, because our data set appeared to be skewed to the right, we couldn't use the empirical rule, so we had to use Chevyshev's theorem. We plugged in our numbers into the equation and got negative $191.16 and $3,463.18. By Chevyshev's theorem, we have at least 89% of the data within 3 standard deviations above and below the mean. Our final answer came out to be $0,3,463.18. The professor made an annotation that because we were dealing in terms of dollars, we couldn't use negative values, and so the smallest value we could use with dollars was 0. Now moving on to question 14, we had to create a confidence interval for the mean using 90, 95, or 99 levels of confidence. We had to provide a critical value, a sketch of the critical value, and the standard error, and all the formulas and calculations. So these were all of our values here that we were going to plug into the formulas. We used inverse t and plugged in 0.005 and comma 49. We got negative 2.67995. We rounded that and made it a positive value to get 2.68 for the critical value. This was our sketch using technology from StatCrunch. For the standard error, we plugged in our numbers here and got 206.28. We then plugged in this number into this equation over here, which gave us the 99% CI for the mean is 1,422.9 and $46. Now for question 15, we had to take a look at our data set and find how many data values were needed to create an 80% confidence interval for the mean. Assuming that we wanted the error to be E equals 0.03 from the population mean. For the CV, we had to use code inverse t. We plugged in 0.10, comma 40, and we got negative 1.299. We rounded that and made it a positive, so 1.3 was our final answer for the CV. Then our S was 544.2635, and our C was 0.80. We then plugged that into this formula here and squared it. Our final answer was this big number you see here. So, okay, let's see. You need at least n equals 556240512 or more data values to create an 80% confidence interval for the population mean. This was our final answer. Now finally for question 16, we had to design a hypothesis for the mean and pick the same C value that was selected for question 14. So for step 1, we did our claim was that the mean equaled 1,636. For our ho and ha, we gave this answer. And then for step 3, for the CV, we had C equals 0.99, then 0.01, divided that by 2 here. For 0.005, the DF was 49, and then we plugged that into here with 0.005 and 49. This was a sketch that StatCrunch gave us. The critical values are here, 2.68, and then the test statistic was right here. We plugged it in for negative 0.0886. Then the p-value was 0.9298. And then what we obtained from the TI-84 plus was these values right here. Our final answer was to reject ho because there is not sufficient evidence to warrant the rejection of the claim that the mean was 1,636. A p-value of 0.9298 is greater than the significance level of 0.01. So yeah, thank you guys for watching.